Hi everyone, this is Thiagarajan. Welcome to the website V.ThiagarajaniRSE.com. So in this video I would like to discuss about the new application which I have recently uploaded in this website. I hope some of you would have visited my website and used my applications. There are many applications available for the civil engineers. So in this order, the one more application I have added, that is for the realignment of the curve. It is specifically for the railway civil engineers and the permanent engineers who are maintaining the track. So the existing curve alignment, in the railway track we have the curved alignment, and that location has to be properly maintained. And for that the periodical inspection will be there, and they are supposed to check the alignment and see for its correctness. If the alignment is not proper and it is to be the parameters of the curve that is worse than existing will be recorded, and they have to take action for the correction of the alignment for smoothness. If the curve alignment is not proper, whenever vehicle negotiating the curve will not be smooth. There will be discomfort to the passenger. So it is every permanent engineers is responsible for the check the curvature for its correctness periodically as prescribed in the Indian Railway Permanent Manual. So in this connection I want to discuss this video. At the same time I will discuss about the new application which I have uploaded for the gender curve, how it is working, what is the procedure you are supposed to follow, I will get the result and all. Okay, we'll see one by one. Okay, so about this website, there are many applications available as you see here. About these applications already I have discussed in the different videos. So now in this order, one more application I have recently uploaded, that is for the realignment of curve. Mainly it is for the permanent engineers, the railway engineers who are maintaining the track. So let's see something about this now. Okay, so pretty well the curve, in our railway or roadway we need curve. Where we need curve? Whenever there is a change of direction take place. Suppose we have the two straight, it's one line alignment, suddenly change in the alignment, direction is changed. So we cannot abruptly keep this alignment, road alignment or railway alignment. So necessarily we have to introduce a smooth curvature in between. So normally in our railway we are using circular curve. Even nowadays, even highways also, we have national highways, comfortably they are able to drive. So they are also nowadays ensuring the proper curvature, the high speed roads and all. As far as railway is concerned, also we are providing circular curve in between for smooth negotiation of the train during the change of direction takes place. So this is arrangement normally used to introduce. So between two sides we are introducing the curvature. So according to deflection angle, according to the amount of deflection angle, we will decide the curvature, and also we have a lot of stipulation available, and what should be the radius of curvature for various speeds of track, because higher the speed and we cannot go sharper curve. So that we are providing sharper curve, we need to provide more supervision that will not be able to provide. So necessarily there will be speed restriction will be there. So according to the section concern, based on the permissible speed limit, and we are designing the radius of the curvature along with the deflection angle. Okay, but this is general. We are providing circular curve for smooth negotiation. But in railways, the transition curves normally we are providing at the ends of the curve, the both ends, that is beginning and end of the curve. Normally we used to provide the transition. That's called combined curve, I mean transitioned curve actually, because this is a circular curve. If you are just connecting the straight away, there will be sudden change in direction takes place. So at the transition point, what will happen? So Normally, for circular curve, we used to provide a super elevation. Okay, super elevation, we cannot suddenly provide here. Okay, so for the purpose of easing out the super elevation as well as the curvature, we are providing the transition curve. Normally, this will be the parabolic curve. Okay, this is the arrangement by providing the amount of the shift. So this is the radius curve we are designing. Actually, this will be the radius, which will be the radius of the design radius plus amount of shift. This is called shift. This is called shift. So for this only, we used to work out the tangent length and all, and we will be able to fix this point where we have to start the curvature and all. That is tangent length plus of the transition length. This total length will be TL. This will be the offset. This will be the tangent length plus of the transition length. This will be the point we will be locating for commencement of the curve, introducing the transition curve. Generally, this will be the arrangement normally used to have. And what will happen? During setting we will follow this. During initial setting construction, we used to follow the procedures. A civil engineer, pretty well the various method of setting out of the curve and all. Even the combined curve along with the transition curve. So following this, we will use to set up. So while setting up, the curvature will be all right. You will have the proper parabolic curve will be here. Your proper circular curve will be there. It will be perfect. But we cannot expect that the existing condition will be continuing forever. In course of during service, the alignment will get disturbed. So the radius, so long the radius is uniform, the smoothness, that riding comfort will be uniform. When the curvature, there is any misalignment, when the radius is not uniform, definitely there will be the radial change of radial acceleration, there will be lateral acceleration, change of lateral acceleration, and because of there will be jolting, jerking, and that will affect the passengers who are traveling in the train. So riding comfort will be affected. So that is why it is every engineer has to periodically inspect the curvature, whether the alignment is proper or not. Okay. And for that purpose, Indian Railways, we have Indian Railway Permanent Manual is there. There are a lot of stipulation available, and it provides schedule for the inspecting official periodically. How many months it is to be inspected, what all the parameters has to be recorded, and based on that, existing parameter, they will come to the conclusion whether the alignment is correct, properly available or not. At the same time, they used to inspect by traveling train, doing some footplate inspection, brake inspection. They will understand how the curvature is performed, whether it's smooth or any jolting is there. So with that record also, they will go for the inspection and they will confirm with the actual parameters, existing parameters. So this is actually the circular curve. So long it is circular curve shape, this will be all right. That means as far as curve is concerned, there will be the change of direction. Every point will take place. Every point is there will be change of direction. Though because change of direction, there will be centrifugal force will take place. Centripetal, those to be counteracted. For that, we are providing super elevation. Super elevation will be uniform for the curvature. Suppose if we take one radius, some radius, 2000 meter radius means for 2000 meter radius, that super elevation will be provided so that the smooth traveling will be there. The passenger will not feel any discomfortness, uneasiness. So the change of direction should be uniform. So long change of direction is uniform, it will be all right. That means what? The radius should be uniform. So radius, if you have to check up the radius, but practically we cannot check up the radius at the field throughout the curve. From beginning, what is the beginning to end, we cannot check the radius because the radius is very large value measurement. It's very difficult to measure the field. At the same time, even if we measure, there won't be accuracy. So normally we used to measure in a accuracy curvature, but it is not possible. For that purpose, what we are doing, suppose this is our disturbed alignment. Okay, this is your proper alignment. We should bring to this alignment normally. And normally, what in our railway for the inspection purpose, the curve is marked with the stations from beginning to the end of the curve. So at a 10 meter interval, normal 10 meter interval, we will have station. Suppose the here says 0, 1, 2, 3 like that, we used to mark the station till the end of the curve. And the versins will be measured. Versine means what? Suppose we are measuring the mid offset using the chord of 20 meter. Suppose 10 meter station, but we are using 20 meter chord and we are measuring the mid. This mid offset is called versine or versine. Okay, this is versine. So this measurement we have to take consecutively. We have to take here 20 meter overlapping chord, again stretching here and holding it, and we are measuring each and every station. Use 20 meter overlapping chord. We are measuring the versine. That will be the exiting versine. Suppose the green line is disturbed curve alignment. The disturbed curve alignment, the versine will be measured. That will be the exiting versine. So the versine we have to check up. This will be uniform. If it is uniform, the curvature is uniform. Okay. I'll say. So this is versine existing. If it is disturbed, this is existing. So this is versine proposed. So if it is a disturbed alignment, we want to bring it to this shape, to the proper uniform radius, and for that we have to fix the proposed versine. That means uniform versine we have to fix. So earlier in the disturbed versine, the versine will not be uniform, but in circular portion versine, if you are bring the alignment to circular form, versine will be uniform throughout the length. This is versine proposed. So for bring the alignment to the proper alignment, what is to be done? We need the amount of slope, but because this is the exiting alignment, green one, the red one is a proposed alignment. So we should be able to find out how much amount of slope, how much correctness we have to give to each and every station. So if you take here, you see this is your existing alignment, this is your proposed alignment. So we have to bring the station inward. So we have to find out the amount of slope, how much. Like that here, we cannot directly measure and we cannot do it. But because once we are shifting the alignment, it will affect the other stations also, adjacent stations. That is why we cannot straight away make the difference. But at the same time, using a certain formula, certain concept, you have to follow that. Following that, we have to find out the amount of slope. How much amount of slope we have to apply here to bring the alignment to correct alignment. Like that, each and every station we have to find out. Here also, here you see this location, you have to bring it out. So that amount of slope has to be calculated. If it is slowing, you see inside is called negative as far as we are concerned, the notation we are following. And if you are slowing outside, it is positive. Okay. Once the amount of slope is calculated, so okay, so we can go to the field, applying the amount of slope in every station. Okay, we can slow the track inward or outward, so that we will be able to get the proper alignment. Once after that, if we check the alignment, versine, the versine will almost be uniform with the minimum variations if at all. Okay, so this is about the procedure, what is to be done for correction of the alignment. However, before going to the application, let me say something about the curve. Okay, the curve, how it is defined. So in our railway, the curve is normally used to say 1 degree curve and 2 degree curve, like that. The degree means actually in railway, it is defined as degree is the angle subtended at its center for a chord length of 30 meter. So whatever angle subtended center for a chord length 30 meter, he used to say it is a degree. It's a degree. For example, 1 degree equal to 1750 meter radius. That means the radius of the curve is 1750. The angle subtended at its center will be 1 degree. So that way it is defined. So based on that, we have the relation. The degree equal to 1750 divided by radius, and radius equal to 1750 divided by degree. These are the relation between the degree and the radius. Is how we got it. Is nothing, pretty well trigonometry. It is for complete circumference. That is, we take 2 pi r, means the angle subtended center will be 360 degree. Suppose if it is 30 meter, because here we take arc length equal to 30 meter, because the negligible will be the large radius. So we used to take arc length equal to 30 meter, and arc length equal to chord length almost. Okay. So if that is the case, for 30 meter arc length, what will be the degree? That way we are relating it. So we'll be able to get the relation. That is for 1 degree. The 1 degree, the angle subtended means the radius will be 70 meter and vice versa. So this is about the designation of the curve, how it is designated in terms of degree. Okay. So this is something about it. And like that, the versine also, versine c squared by 8r. So suppose versine, what is the versine? Because radius we are not measuring for inspection purpose, for checking the alignment whether it is proper or not. We used to measure only versine. The versine will be equal to c squared by 8r. This is also derivation we got. How we got the c squared by 8r and all. It is all everything is there. Or I mean, this one or even survey book, everything is there. So suppose if you are substituting c in meter and r in meter, we will be getting in meter if it is. Suppose if you want to get value in mm, it is 125 c squared by r. Just simply 1000 mm now. If you are putting that below that, you will be getting the in mm. This is, but in this case we have to c will be in meter, r will be in meter, but result, the versine will be in mm. In that case, we have to use this formula. 125 c squared by r will be the versine. Normally, our 1 degree, why I am just this detailing everything, suppose if you take 1 degree curve, you say versine will be 29 mm. If it is 1 degree curve, we have that versine will be 29 mm throughout the length. Okay. If 2 degree curve means just 2 degree. 2 degree curve means 2 and 29, it is 58 mm. So, like that. So, will be there. So the versine should be uniform. But practically, during the maintenance, it won't be always the same. Suppose if we say 1 degree curve, not be 29 mm. Here one section will be 20 mm, other section will be 35 mm, like that will be there. So that is why we used to check up the curvature, record the versine existing, and according to the amount of variation, when it is exceeding the prescribed limit, then we have to go for the realignment of the correctness of the, for correcting the alignment. That means realignment of curve we have to plan. So this is actually the Indian Railway Permanent Manual stipulates the criteria for realignment of the curve. Okay, we have various section according to the speed. So what should be the limit and all? 10 mm or 15 mm 100 or 20% of the average versine circular portion, whichever is more. In this case, we have to plan for realignment of curve. Like that, each and every, based on the speed of the section. So they are given stipulation and the value 20 mm or 20% average versine circular portion, whichever is more, it is for 110 km and up to 50 km. Below 50 km, 40 mm or 20% of the average versine portion, whichever is more. This should be fun. If it is only in the few station, normally we can go for the local adjustment hours. Only the particular station, some station here, some remove that side 5 station, this side 5 station, we can correct the local adjustment, we can do it. Suppose if the variation is more, that means more than 20% station are having versine variation above the limits, limit prescribed here, we have to go for the complete realignment of the curve. This is the stipulation given in the Railway Permanent Manual. You are supposed to follow that. Okay, this introduction, we can go to the website. And some of the concepts, what we are using in the program also, you can just have some idea. Actually, the sum of versine existing equal to sum of versine proposed. So whatever versine proposed should be equal to the versine existing. Okay, is one of the concepts. And another concept is, this is a second summation of the versine difference. That is the difference between the versine proposed and the versine existing. Okay, sum of them will be second summation of the versine difference equal to half the slope. So this is and double the second summation of the versine difference is full slope. These are all the concepts actually we are using in the program. Okay, now without further ado, we will go to the website. This is our website, that is vtrengineeringsoft.com. So you can go to the website there. Okay. So this is our website. Okay. So there are many applications as we have already discussed, and that new application is Realignment account. Okay. Go into the application, we can clicking that. You can go to this page, and there is import data. So we got to import the data. Existing version data has to be imported. You can do it through Excel data, Excel file. You can import data, or you can directly you can also enter. Sometimes you are using mobile phone, or you are in the field in a midsection, Excel file and all. It's very difficult to get and all. You can directly using this data entry option. You can feed the existing version. You can do it. So this is only the online application, not like other application where there are a lot of applications available for Realignment. There you go to install a program in the computer and use to do it. And here anytime, anywhere, once you have mobile phone or computer or with this one internet connection, you can just open the website, go to the website. You can just click my website and go to the application. Okay. So this is importing data. You're supposed to do it. Import data means then you can use here also and sample I've given based you can follow this. So you can first time means then you can just sample data you can download. Okay, this is simply station number you put. Another thing I want to say, whenever you use that data, it is in 97/2003 format. Okay, so this format you use. You don't go for XLX, XLS only use. You don't go for XLSX. You use only the old. This is 97/2003 format. That right now that only it will accept. Okay, it's simply station number and version next. Like that you can. This is the format. In that format, you can record your existing versions. You can import into the application. You will get the results. Okay. So like that, you can just go to the import data. It will ask, import the existing data from Excel file only. Please use 97/2008 to avoid error. Okay, for sample you can download and follow it. Okay, for reference purpose I given this one. Direct entry, of course, as I already told you, button is there. Clicking that you can enter direct. Okay, that is also possible here. Then we go to decide first. So there are many options available. One is this is for realignment of the curve, entire curve, and also for local adjustment purpose. Another third one is only transition portion. So according to the necessity, then you go to plan. Suppose you want to correct the entire curve, full realignment you want to do it. In that case, the entire stations version existing, you must take. Suppose for local adjustment, only the portion of some circular portion has to be realigned. So in that case, only that station alone, some 10 station record alone should be there. Only circular portion should be there. So you have to decide first. Then thirdly, the transition portion. The transition portion, if you want to correct only, you only take your leading transition or trailing portion. You have to only the transition portion with some portion of circular portion. Suppose 8 stations you have a transition extension. Then extra you have to go for some 5 stations, 6 stations extra, some disruptive curve portion also. So those data alone must be available here. Okay. So just importing full data, then you cannot choose transition curve correction. You cannot choose local adjustment. Sometime it will show error because it will get confused because you are giving entire data. It won't do it. Okay. So that first you have to decide, and accordingly, once you run the program, once you go inside and all these things, you function and all, you just check it up, it come out, then you can understand how it needs this and all. Okay. So now we have to choose the file. Choose the file here. Some transition portion or a input is there. Okay. Something I put. This is the existing version already. It's just imported. Now we have to go for the calculation. because full existing we are saying from complete station I have just imported. It is for complete realignment of the curve. So here calculate button, if you click, there are many options. Normal method of choosing, this is normally will give the more slews. Either this equalizing slews, positive and negative. That means if you are using this one side there will be some 200 mm slew, other side there only positive, and negative will be 50 and all. But equalizing means it will be average, okay, optimum slew, both positive and negative side will consider. So for this is the option, okay. And this is a compound curve. This compound curve means that suppose there are a major, a very big curve having some 120 more number of sections are there, very big curve. So if you do the complete alignment using this any other form and methods, you will get some section will have the most slow. So in this case what you used to do, you can just compound it. That means we can put a different radius and different portion, and so that you will be able to get the optimized slews, okay. For that this option is there. In this case we can go, we can divide the curve into some maximum 4 segment, okay, and each segment normally 12 stations will be there, minimum station. You cannot keep the station very close, so minimum station interval should be 12 station units, okay, like that, okay. That is the third one. And fourth one is minimum slews with single obligatory point. Only one obligatory point is there somewhere that you can locate it, and using that you can get this is the option. This is for optimum transition. Suppose transitional length you want to optimize with the minimum slow, so using this application you can do it. This is Gaussian distribution method. This is also full realignment up to this one 1, 2, 3, 4, 5, 6 is complete realignment, okay. This is okay, complete realignment. Gaussian distribution is this also for minimizing the slews. This option will be there. The thing is there are too many methods available for realignment occur. The only string lining method used to do some summation and all to do. Other one is those days used to do some Gaussian distribution, difference distribution, just like a moment distribution what we follow, in a structural analysis. This will be the moment Gaussian distribution. The difference will be worked out, then uniformly we distribute adjacent station after changing the sign, and off will distribute, off again off, like that. So that way it will be, used to say earlier, American method used to say. So different methods. So all following that, this program has been set. Okay, you can use any options, and you can get the result and see for the whichever it is advisable, whichever is feasible for you. Okay, this. The sixth and seventh is, sixth one is local adjustment. As I already told you, it is only for the circular portion. Some 10 station, 12 station, middle portion alone we want to correct it. This option you can choose. If you are choosing it, this you have to import. You would have imported only the circular portion version alone. Okay. The other one is transition portion. Transition portion correction means only transition portion. Leading or trailing you can choose. You can take some transition portion, and along with some disruptive portion, circular portion also should be there. You cannot only transition portion, you cannot do it. Some transition portion also you have to come. Suppose 8 station means here at least 50%, that means 150. That means 4 station, you can take more also. Some 6 station extra should be circular portion also. Like that you have to import data according to your need. Okay, whichever option you want to choose, accordingly your Gaussian existing data should be available here. Okay, now we can go for the normal method of choosing. If you are clicking it asks, okay, we'll put only some 4 stations, some 4 stations. So we will get the result here. This is your slew. This is your proposed version 9.1, and you got this is a slew available each and every station. So here you can see station number 7, 27 plus 27, and station number 12 it is minus 81. Here you have to be very careful in the slew, whether it is outside or inside. Positive slews outside, and negative sluice inside. He is very, very careful, because almost all the software, this is only the following. Okay, normally the outside slough only positive and inside slough. That is why I also followed this one. But manual, if you see manual and other literature, railway literature, and they have this one. It will be different. Okay, positive sluice inside and negative sluice outside. But only software, every software, almost we have so many softwares, and all software they have only this method of deciding sign conversion they follow. So that is why I also follow the same sign convention. Okay, and accordingly I made the program, and for that the positive sluice will be outside and negative sluice will be inside. Okay, here as I told you, see here 7th station 27 mm and 12th station minus 81 mm. This is a slough, amount of slough. But here you see positive sluice 27 and negative sluice minus 80, which is more. Okay, you want to optimize. Suppose the maximum, both the negative and positive sluice should be uniform, almost close. So that, okay, if you want to optimize the slough, and other option you can again you click the calculate button. You can go for equalizing the slough. If you do it, click again. You can whatever choose option chosen, it should come here. After that only you have to click OK. So if you are clicking OK, you got 56. You see 7 stations 56 and 13 station 56. So now both positive and negative is equalized. It is optimized. So this is the second option. Fourth option, compound curve. Compound curve means it is a very, very longer curve. Okay, it's very long. So many stations, maybe 120, like that. If it is there, 100, it is there. Then you can just compound it. So to too many segment you can make it, and each segment will have some proposed version, so that minimum version, slough we will be able to achieve. Okay, that is another option. Then here with single applicative point, as I already told you, this is optimization sluice the optimum transition length. Okay, suppose for example this one we will choose now. This other thing we'll see later too. Okay, this also you can do now. Minimum sluice, single applicator point. Suppose only one applicator point is there. So for example, center will have some 8th station. 8th station we have an obligatory point. It is 51 mm. It should not be any slough here. So minimum one obligatory point. Okay, okay. After clicking, you should come. Whatever option you have chosen, you should come here. Okay, same transition length. So now it's asking station number. Let us put 8 station or some 9 station we can have. Okay, 9 station. 9 station we have the 0. You have to put add. Okay, add 0. Now after you have to work out the solution. Just giving some alert and all. You see now it is -2. Got 9th thing. Okay, 9 we have the obligatory point, only -2 is there. You click again calculate button. Again this panel comes. So the next option is minimum sluice with the optimum transition length. Here need not set the length of transition. It will automatically give the optimum transition length. Suppose choosing the option, clicking OK. So now we got the minimum sluice with the optimum transition length. This option has come here. Okay, and also the result has come. Okay, after the working, now it gives the result. The leading transition is 3 station units and the trailing transition is 3 station units. These are the results actually. Okay, so it will automatically design the optimum transition length in this case to get the minimum sluice. Okay, this is one of the options available here. Okay. Again we'll click this calculate button. You can see the next option. The next option is Versine distribution method. next option. Okay, so clicking this option, click OK. So in this option, no, when you are clicking, again the dialog box comes. So we have to choose whether we are processing with the obligatory point and without obligatory point. Suppose if without means we have to choose the number 2, and with means we have to enter 1. So now let us go 2 without obligatory point 2. Click OK. Selected no obligatory. OK. So now it has come. Version distribution method, no obligatory points. Okay. So let us have our station units, 4 station units of transit length, both leading and trailing. Okay. So click OK. Now the result has come. So that we comparatively you can see, as far as this option is concerned, comparatively we will get the minimum slews. The earlier program and all, it was programmed in a different method. This option, this version distribution method, it has been programmed in a different way. Mostly it is just doing some taking the version difference of version proposed and version existing and distribute. The difference is distributed the adjacent stations, like that each and every station is doing, and ultimately it is giving the slew so much. Okay, so this option is comparatively it will be minimum. So this is the one of the options available, but in this case this obligatory point, if you are choosing not like earlier method, here you have to compromise. It will accept the obligatory point and it gives some we can't exactly get the slews whatever we propose. Suppose 0 slew we want to have one station, we will not get it, and even some slew minus or plus, even we set exactly we won't get it. So we have to compromise slightly, it will go this way and that way. Okay, so let us see that option also, that with the obligatory point. Okay, that option will go. So clicking OK again, so the dialog box comes. Now we can choose 1, that is for obligatory point. With the obligatory point we want to process. Click OK. Okay, selected is obligatory points. OK. Okay, now just come version distribution method with the obligatory points. So this is our we will continue with the same length of transition, 4 station units. Click OK. Then this obligatory point dialog box comes, the frame comes. Then let us choose again 9, station number 9. Okay, 9 only, we have some -4 something is there, 25 is there. So 0 slew we want to have this station. Let us see how much we get. So it's just telling minimum distance between the 2 obligatory point 12 stations. Okay, doesn't matter. Okay, now then we have to click this solution button, but in this case one more button is just opening, that is option button, because here as far as this case is concerned, the point, the station where the obligatory point, and in that point the station, it takes the adjacent stations, do some averaging of versions, and finally just working out the slow. Okay, so clicking this option, we get this dialog box. It's asking the number of stations averaging at the obligatory points, 3 or 5. There's only 2 options is there, either 3 or 5. That means the obligatory point, the both sides, one station, upper side one station and lower side one station, 3 stations. We want to do averaging, we can put 3. If you want to do averaging of versions, upper side 2 and lower side 2, you have to choose the number 5. Okay, now we will choose 3. Some alert message is coming. Please check the VP at the obligatory point, the reference to the adjacent station and slews. If more variation, ignore solution. Try other options. Like that is coming. Okay. What is that? That means when you are getting the result, you have to verify whether it is okay or not. Sometimes the Versailles proposed will be, there will be upward variation will be there, normal variation, and even slew also there will be more. So everything, just look at it, and if you satisfy with that, you have to proceed. Otherwise, you have to ignore this solution. Like that is asking. He is asking to try other options also. Okay. Now you see. Earlier we got 25 mm slew. Now we got 10 mm slew. So comparatively, it is now the slew at the obligatory point is reduced. But at the same time, see here. We are just doing the averaging. So it just doing some Versailles proposed setting, and it just averaging the Versailles 3 stations and working out the slews. So this area to get the minimum slews. So because the -4 most we get this much. So the same time also the Versailles also, because doing the average, you see here 20 -4 only 19, just averaging it. If it is just almost uniform, they will get the uniform Versailles will be there. This is the problem as well this case concerned. But it being it is a flatter curve. There is a variation. It seems to be slightly more. But if you have a very longer curve of having some 1 degree curve, 29 mm or 2 degree curves and all, if you do, there will be Versailles will be at 29 mm, 58 mm. In that case, this variation will not be much. Okay. Anyway, we'll see the next. Curve will check up how much we are getting the slew, and we'll see here. Okay. This is about this one, and also one more fine tuning also you can do. There is a try next button is there. If we are clicking it, again is asking averaging 3 stations. Let us see. Now we got again same slew almost. Earlier it was 10 mm, now 11 mm. But averaging is, instead of 5, we got 5.5. Okay. Some fine tuning has been again done. Okay. This is the maximum we can do as far as this case is concerned. If you are acceptable, we can proceed. Otherwise, we have to ignore this solution. This is something about the Versailles distribution. But when no obligatory point is, it will be perfect. We will be getting the very minimum slews. But in case of obligatory points, we have to check up whether the result is comfortable, whether it's okay or not. We have to see. Okay. This is something about it. Okay. Then the same case we will go to the some longer curve percent distribution, same thing. Okay. Instead of choosing this small curve, we will go to the so we can import data. This is somewhat now this is having some 43 stations or 66, mostly some around 50 to 60 Versailles is there. So in this case we'll see, let us set our length of transition 6 station units and click OK. The station, let us go to the middle one. This somewhere any station, suppose let us 20, station number 20. So station number 20, we'll see 20 0 0 add. Okay, then solution option averaging 3 station averaging. Okay. You see here 20th station we have -4. It's also okay. Comparatively is okay. See 61, 58, 58. This is very well. Okay, accepted, and we get the reasonable result of -4. Okay. Even 0 mm, slide in between 0 mm, 3 plus 3 to -4. So in between somewhere 0 slow it is there. Okay. So this is a longer curve. This is a longer big curve, and results is okay for us. Okay. So in this case, you see that all the 6 cases, 1, 2, 3, 4, 5, 6, all 6 cases for the A complete realignment of the curve. Full curve we take and do in the realignment. Okay, this is one. So after this, this is the result we got. We can go for the printout also. See, print this one. Curve number it's asking, let us 1, and section is asking previous section. Let us put here. Click OK. Clicking OK, you will get the result. Okay, output has come here. So this is station number, existing version, proposed version, then slow. Okay, so we got. This is maximum outside slow, how much, that is showing. Inside slow, how much, which station, how much mm. Station 22, 50 mm. Here station 9, 44 mm, plus 44. Station number minus 4 mm. Okay, this is the obligatory point. Okay, so this result also has come. We can see, refer, and if you want to export, if you want to download this result in the Excel format also, the export to Excel we are clicking. 71. It has come in a Excel format, again 58 mm, we got it, minus 4 mm, 20 mm result. This we can take the output. The footnote is also available, detailing the maximum slew and minimum, outside slew, inside slew, and obligatory points, everything. Okay. Okay, this is the result actually. Okay, let us close this one. Similarly, we can go to the home page, this one, and we want to see the graph also. You can click this button, graph, just for view. Review this in the graphical form. So this is. So now this one, the green one is version existing, and red one is version proposed, and blue one is slow. So proposed version is almost uniform, just like a trapezium, and a slight variation because of the obligatory point where we have the version is slightly changed, because here 61 to 58 gradually goes down and just up. Okay, this is a graphical form of just to review the version proposed and version existing. This one is version existing. This is uniform, the red line. Now it is version proposed. So this also you can see. Take the printout if you want. Okay. Again going this. Closing this one. Okay. This is something about it. So the same curve we can go for use this because the compound curve. So normally for compound curve and all, for a long as I already told you, longer curve. If you want to get, if you are doing the working out the slews, it will be normally more because of the curvature is very long. There will be accumulation of the error will be more. Okay, that is why normally they will get the more slews. So in this case, what you do, you have to divide into so many segments, and segment by segment you are dealing, and so that you will be able to get the optimized slew. This case, even this same option we can use for obligatory point also. Suppose we have some 2 obligatory points here in this curve, and we can set obligatory points. 2 obligatory point means what? There will be 3 segment will be there, starting to middle one, and 1 to second segment, second option obligatory point, that second segment, and second obligatory point to the end, that is third segment. Okay, dividing into 3 segments in case of the 2 obligatory points. So this is actually the very longer curve. We have station of around some 49. In this case, we will check up the option 3, that is a compound curve with minimum slews and obligatory points. Okay, same 6. Okay, click OK. Not you have to once we want to change the option. After clicking this, we have to click OK. Then now we have to check up whatever option you have chosen, whether it has come here, then only this option will be considered and further processing will proceed. Okay, compound curve for minimum loose and obligated points. Again, click OK. Okay, let's set our obligatory point. Here almost we have 45 stations. Then we can divide into 3 segments. Suppose we want to compound the curve and we have to decide, okay, how many segments and we have to divide the curve. So okay, as far as this case is concerned, the interval between the obligatory points and beginning to the first obligatory point and the last obligatory point to the end station, there must be a minimum interval of 12 station units must ensure. If you are closely locating the obligatory point or the change of point, compounding stations, and there is possibility for the erratic solutions. You will be getting sometime most loose. That is why this thing you must ensure. Let us take here some 11 station number 11 or okay 11. First this one, just it is giving the alert also. For better results, choose obligatory points more than 12 station interval, including the first and last stations. Okay, so that you should take care. Okay. So next we will give 22, and third one is, let us put 30, 33, level 11, that including. Okay. So this is your obligatory point, or this is segments. Okay, at 11 station, the first up to beginning to the 11 station one segment, and 11 to 12 to 22 station one segment. The last one from 22 to 33, and last one from 33 to last station. So almost we have four segments. So in between two, and beginning and end we have two segments. So total 4 segments we have now. So they will proceed, and we'll check out what will happen. What's how much slow we are getting, and what are slow we are getting in the obligatory point. Let's check. Okay, here again is giving the alert. Please check the VP at the obligatory points with reference to the adjust stations. If more variation, ignore the solution, try other options. So you should carefully check up. You have to check up, and the variation is more. That was even worse between at the change point. Adjacent stations we have, those stations if you have more variation, you got to drop. At the same time, slow also you have to see. It's giving more slow also, you have to drop this one, and you have to go for the other options. Okay, let us see why. Okay, now it got okay. Now we got the result. Almost 11 station we have -5, and 22 station we have -9, and 33 station -12. And slews also is okay, compared is less. Okay, so this way we can use this option 3, okay, compounding, or we can select the stations where we have some obligatory points. Okay, this is a way we have to use this option, and okay, this one method. Okay, then we'll go to the other left out methods. We have last the local adjustment, transition curve corrections. The 2 methods we have. Let's see one by one. As for local adjustment context, you should have the data. So as I already told you, this option is used only for correcting the alignment only in the circular portion. Okay, some circular portions. Instead of align the entire curve, so we want to correct only the few number of stations, and those stations, and we can take our sense that side and this side, slightly some three stations or 4 stations, this side, that side. So taking those stations and importing data here, and we can use the option and get the result. We'll see. We'll go to the import data. Let us check any data is there. Choose file. I think some local adjustment, something. Okay, one file is there. Okay, some local. This clicking this open, and uploading here it has come local and uploading this one. So now it's only the some station number 7 to 18, some stations are there, and here also launching some 100 stations, 100 version is there. So this should be locally adjusted. Okay, instead of taking the entire curve, we take only the some portion of circular curve. We want to correct it. Okay, we have to choose this option, local adjustment. Click OK. Okay, again please ensure data of circular portions of curve only. Okay, it's come. Of course, we have some more signs, more slews here. Anyway, these are all string lining, string lining and summation method only. Worked out and we got the result here. Okay, this is a local adjustment. And go to the other method, the last one, transition curve correction here. Okay, you can go to here. So for that, what you have to do, you have to go for first importing data. So importing data, we have to import data for transition curve, lead transition. Let us take this one. Okay, lead transition. Transition portion, some 2-3 stations extra and circular portion, distributed portion. That also you have to take. Okay, don't stop only with the transition curve. So for easing out, we need some stations in the circular portion also, so that the alignment correction will be smooth, proper. Okay, again open, then upload. Okay, this is the station. Transition curve. Okay, already selected. Okay. Please ensure data of any one end transition portion of curve. Only one by one. You cannot put a two transition. No, only one transition. If you take leading or trailing, you have to take that version only. We have to import. So okay. Now it is leading, or this is 0, minus to 1, like this, leading only. So leading. So here let us take 6 or where stations. I don't know. Okay, 4 station. Let us put not 4. This will put some 7 or 7 station. Will put. Okay. Now it is corrected. Okay, 7 station. Now this is a result. Now we have station 5, 10 maximum, 41 minus 23. This is leading. So leading means leading, you have to choose and leading. This one. Suppose if you trailing means you have to opt this trailing portion. For example, here again we will go to the trailing. So what is trail? On trail. Okay, this you will choose. Upload. Uploaded here. Here is C20, like that. It is coming to this way. Actual station number I will put. Okay. This is the last station, and from 28th to 32 we have considered tension plus circular portion. So in this case, let's see what's the result. So we have to opt trailing here. Then again here station sum, let us put. Okay. Now we got the result. This is a slew now we got. So this way we can use this option for correcting the alignment in the transition portion. Okay, one more thing I want to say. So whenever you are importing your data, the data must have, you can starting no problem, you can put -1, -2, everything no problem, but the ending station don't add +1, +2. Okay, you put continuous number. Okay, instead of +1, +2, you can continue on 34, 35 like that. Don't put +1, +2. You should end with the continuous number, full number only. Okay, that thing kindly note it. And whenever you are importing data, whether you are full realignment or the leading this trailing transition portion normally will be getting the last stations. Okay, you just follow that. Kindly you follow that. Okay. Then other options already you discussed about the printout and the graph. You want to get some, exporting the output, the Excel format, and you can use this print button. And graphical representation, no, if you want to review, you can just clicking this button, you can see already we have discussed about it. Okay. Then one more button, I will help. This help button, if you are clicking it, see, you will have the help page you can get, and whatever discussed, it is available. Okay, step by step procedures already it is given, complete introduction, and what all the buttons available, and procedures and options available. So one by one, you can step by step it is given. I can just follow that if you have any doubt. So with that we will conclude. Then this thing we must be very careful. The sign conversion, whatever it is available, just to follow that. And so any feedback you want to communicate to me, or any issues, problems in this application, kindly send me the message. Okay, to my email ID. I have two email ID, vthrajan13@gmail.com and vthrengineeringsoft@gmail.com. And WhatsApp number also available, two numbers available here. You can make use of that, and you can send me the message for anything. Okay. So kindly make use of this program, the application. I hope so whatever explanation I given would be sufficient for you. Okay. Thanks a lot. And next video, we'll see in the next video, and if I upload some other module, okay, the application related to engineering. Okay. Thanks a lot. Thank you.